Hello everyone, my name is Elijah Proctor, and today I'm going to walk you through the design, implementation approach, and success measures for the Voice Assisted Healthcare Companion, or VAHC. This is a project I've been developing with the focus on providing both practical and emotional support to seniors who live alone. The VAHC is an AI-powered voice assistant designed to make life safer, easier, and more connected for older adults. It handles essential tasks like reminding users to take their medications, helping them schedule healthcare appointments, and sending emergency alerts, and even delivering faith-based content for emotional and spiritual well-being. It's completely hands-free, uses simple voice commands, and has built-in HIPAA-compliant security to protect sensitive health information from the very beginning. The system is being developed over a 14-week schedule, broken down into 2-week agile sprints, so we can deliver features quickly and make adjustments along the way. The architecture is based on microservices and uses edge computing, which means faster response times for the user. The speech recognition engine is tuned specifically for seniors, taking into account different speech patterns, and we're integrating directly with healthcare APIs and other content services. Because the system is modular, we can add or update features without having to rebuild everything from scratch. Here's the breakdown of our timeline. In weeks 1 and 2, we'll work closely with users and stakeholders to finalize all requirements. Weeks 3 and 4 will focus on building the system's core architecture and a basic working prototype. From weeks 5 to 8, we'll add the main features, healthcare scheduling, medication management, and the speech recognition system. Weeks 9 and 10 will be about adding security layers and making sure the system is fully HIPAA compliant. Weeks 11 and 12 are set aside for user acceptance testing, where we'll gather feedback from seniors directly. Finally, weeks 13 and 14 will focus on optimizations and getting the system ready for production rollout. Now, any project like this comes with challenges. One of the big ones is speech recognition accuracy, especially for older users. To address this, we're training our models on senior-specific voice samples and using federated learning so we can improve accuracy without storing raw audio. Adoption resistance is another factor. Some seniors may be hesitant to use new technology, so we're allowing VAHC to work alongside tools they're already familiar with during the transition. Compliance is always a big one in healthcare tech, so we'll work closely with regulatory experts and conduct regular audits. Finally, we'll ensure smooth performance by using a combination of edge computing for speed and cloud infrastructure for scalability. Our testing will start small and scale up. First, we'll run unit tests to make sure each feature works on its own. Then we'll do integration testing to see how well those features work together. After that, we'll run full system tests that simulate real-world conditions. The last step is user acceptance testing, where seniors will use the system in realistic scenarios so we can measure ease of use, accuracy, and overall satisfaction. For this project to be considered a success, we have some clear targets. Voice command recognition should be at least 95% accurate. Common tasks should respond in under 2 seconds. User satisfaction from testing should be at least 85%. From a budget perspective, development will cost about $80,000, with an additional $5,000 for compliance and about $1,200 a month for hosting. If we can reach 1% of the U.S. senior population at a $5 monthly subscription, we could generate around $2.5 million in annual revenue, which would make the project profitable in the first year. We're assuming that our users will have access to basic internet and a compatible device. We're also relying on healthcare APIs to remain available and stable. Compliance rules can change, but we've built the system in a way that allows us to make updates as needed. Finally, we know performance depends not just on our infrastructure, but also on the user's local device and internet connection. So we're building the system to adapt to different conditions as best as possible. In closing, the voice-assisted healthcare companion brings together healthcare, emergency support, and spiritual engagement in a way that's simple, secure, and meaningful for seniors. By using an agile approach, focusing on user feedback, and building a strong technical foundation, we're setting this project up for long-term success and real-world impact. Thank you for listening, and I look forward to sharing more as we move into the later phases of development.